Hello everyone. We have a question where it says that the polynomial 2x cube minus x square plus a, where a is a constant, is denoted by px. So this cubic equation is basically represented by px. It is given that 2x plus 3 is a factor of px. That means if it is a factor, the remainder will be 0. According to the a part, find the value of a. Very easy. 2x plus 3 is a factor. So that means 2x plus 3 is equals to 0, and from here x is equals to minus 3 upon 2. Place this value of x is equals to minus 3 upon 2 in that particular given polynomial, which is 2x cube minus x square plus a, and instead of x write minus 3 upon 2 at the place of x and make it equal to 0. Why make it equal to 0? Because the remainder is 0. Reason is very simple, because it is a factor, and we know when it is a factor, remainder is 0. And after simplifying it, as you can see, after simplification and rearranging and cancelling and all that, finally we get a value of a as 9, as it was asked in the question, find the value of a, and we have finally found the value of a as 9. According to the b part, when a has this value, solve the inequality px is less than 0. That means we have to solve the inequality. That means we have to find the value of x, because x is a variable. But because it is an inequality, you will not get a single answer, you will get a set of values. You will get a set of values. So let us find the set of values. According to the question, when a has this value, just place the value of a as 9 in the given polynomial, which is px, which is 2x cube minus x square plus a, and instead of a write 9. In the question they gave us that 2x plus 3 is a factor and it is a cubic polynomial, and definitely we just know one of the factor. In order to find the remaining two factors, definitely go for a division process so that we could find the remaining two factors, or a quadratic factor. So simply taking 2x cube minus x square plus 9 and dividing it by the factor which was given in the question over here, 2x plus 3, and after division, if you multiply this 2x with x square, you get 2x cube, and multiplying this x square with 3, we get 3x square. So writing x square below the x square term, a common basic step, which is changing the sign. Positive becomes negative, cancel it out, and minus x square and minus 3x square would be minus 4x square plus 9. Then multiplying this 2x with what value, so that we could get this minus 4x square. So simply multiply this 2x with negative 2x and we get negative 4x square, and then multiply this negative 2x with this positive 3, we get negative 6x. Because there is no x term, so write the negative 6x afterward. The same common process, changing the sign, and after that cancelling the first term. And the rule says that whenever you write the condition, the polynomial should be written in a descending power form. That means do not write 9 first and 6x afterward. No, write 6x first and then 9, because over here the power of x is 1 and over here it is a constant, means the power of x is 0. If you just look at all the step, power 3, power 2, and then power 0, power 2 and power 0, that means whenever you write any polynomial, make sure the polynomial is written in a form in the descending power of the power. That means the highest power is written first and then the lower and then lower. So finally, because it was a factor, everything is cancelled and the remainder is 0. So it should be 0 because it was a factor. And finally, we have come to a condition where we can say that this 2x plus 3, which is a linear factor, when multiplied by x square minus 2x plus 3, which is a quadratic factor, if we multiply both of them, will definitely result in that particular cubic equation which is in the question. So that is why I have written over here that px is basically the product of this linear and the quadratic. Because in the question they have written solve the given inequality, and over here I wrote it as this is less than 0. So basically we have to check that if we draw the graph of this cubic equation, how will the graph look like? From this particular 2x plus 3, it was said in the question that it is a factor, that means the remainder is 0. So from here we can say that okay, if 2x plus 3 is a factor, so from here 2x plus 3, it was written over there x is equals to minus 3 upon 2. That means the graph will definitely go through this particular point, which is minus 3 upon 2, because it is a factor, and x is equals to minus 3 upon 2 is a factor because it is giving a remainder 0, which means the value of y is 0 when x is equals to minus 3 upon 2, which is over here. Now we have to check what is the condition of this quadratic form. Will this quadratic form intersect the x-axis or not? For that, simply go on with finding the minimum point, because the coefficient of x square is 1. If the minimum point is above the x-axis and the coefficient of x square is 1, and definitely we know that if the coefficient of x square is 1, the graph will be a u-shaped graph, and if the minimum point is above the x-axis, that means the remaining part of the graph would be definitely above the x-axis, and after that, observing that, we could definitely work out the answer for this particular inequality. So after converting this particular quadratic equation into a completing square form, because the coefficient of x square is 1, so dividing the coefficient of x, which is negative 2, by 2 and then squaring it, it is 1. So add 1 and subtract 1 this inside this bracket over here, x square minus 2x plus 1, adding and subtracting, and 3. So whatever you have added along with x square minus 2x is basically a perfect square, which means x square minus 2x plus 1 is basically x minus 1 whole square, because it is a perfect square according to the formula a square minus 2ab plus b square, which is equal to a minus b whole square, and this minus 1 plus 3 when simplified would become positive 2. And we know the rule of finding the minimum point, or I would say the turning point or the stationary point, is that whatever is over here is basically the x coordinate of the stationary point or the turning point, and if it is negative, the x coordinate would be positive, and if it is positive, the x coordinate would be negative. Because it is negative, the x coordinate of the stationary point is positive and the y coordinate is positive 2. So 1 comma 2 exactly lies above the x-axis. So 1 is over here, 2 is over here, 1 comma 2 lies above. That means if we draw the graph of this quadratic equation, the minimum point would be 1 comma 2, and definitely the graph of this quadratic equation would completely lie above the x-axis. That means this part of the curve would be above the x-axis, and because this 2x plus 3 was a factor, and this would definitely just cross the x-axis from minus 3 upon 2, because x is equals to minus 3 upon 2 when remainder is 0 means y is 0, and definitely when y is 0, it is on the x-axis. Now finally coming to the inequality, that this inequality is less than 0, and this inequality, this polynomial is basically this particular graph. It is a cubic graph, and this is less than 0. Less than 0 means negative, and when we say negative, negative means negative y. Now what will be the set of values if we need a negative y, because it says that less than 0 means negative value. So what will be the set of values of x which would give us a negative value of y? By observing the graph, it is seen that if we take any value greater than minus 3 upon 2 would definitely result in a positive value of y. That is not our answer, because we need an answer set of values which would definitely give a condition where it is less than 0. So definitely in order to have a condition less than 0, we need all the values which are less than minus 3 upon 2, because if you take any value less than minus 3 upon 2 and draw a point on the graph, it is observed that the y becomes negative, and definitely this inequality is true for all the values which are less than minus 3 upon 2. So finally, from here we can say that according to the question, solve the inequality, and definitely inequalities means solving it means finding the set of values, and we can say that this inequality is true for all the values of x less than minus 3 upon 2. If we take all the values less than minus 3 upon 2, the graph would be something like that, and definitely taking any value less than minus 3 upon 2 would result in a negative value of y, and negative value means less than 0, so it becomes true for the given answer. So this is the final inequality, the set of values for the given cubic inequality.